You might have heard some rumblings about modular mass timber being the future of prefabricated wooden skyscrapers. But what does that even mean, and why is it gaining so much global momentum? We are going to focus on cross-laminated timber for this discussion, since it's as the more widely used option for mid- and high-rise projects. Basically, CLT is an engineered wood product that's made by gluing together layers of lumber that are perpendicular to each other to form a single panel. So you can imagine that the most efficient dimension of a module would be based on some multiple of that number. First and foremost, speed. Mass timber construction is about 40 to 60% faster than traditional construction methods. It reaches 18 stories and contains more than 400 CLT panels. So make sure to subscribe if you don't want to miss it. If you think about it, the majority of structural failures happen at joints where two or more members come together. And it's no different with modular mass timber. Load transfer is one of the most important aspects of designing a mid- or high-rise building with CLT, because the individual panels themselves are very brittle and couldn't simply be butted up against each other without some sort of joint connection. Steel plates are commonly used for floors, walls, and other applications where the loads are concentrated at discrete points, such as a column connection. HVAC, electrical and plumbing systems add a significant amount of complexity to any building project. And that's especially true for tall buildings where there are multiple trades working at the same time. Typically, a crane is used to lift the modules into place, but it's important to coordinate with the other trades to ensure that the ASH modules are installed in the correct sequence. However, this requires careful planning, coordination, and a highly skilled workforce. When done correctly, modular mass timber construction can result in a high-quality, sustainable, and cost-effective building solution. For example, the openings for windows and other exterior features need to be coordinated with the modular layout to ensure proper installation. As each floor is installed, the crew needs to be aware of the location of underground utilities and other obstructions to prevent damage during the installation process. Careful planning and communication can help ensure that the modular mass timber elements are installed quickly and efficiently, minimizing any potential disruptions to the construction schedule. That's why some companies have developed integrated mass timber modules that include floor systems with built-in MEP spaces. For example, the Canadian company EXP has developed a mass timber floor system with integrated utilities that simplifies installation and reduces costs. Make sure to tune in next week for part 2, where we'll dive into the structural details of how these buildings are designed, transported, and assembled on site. See you soon. These floor systems feature a hollow core that allows for the routing of cables and pipes, reducing the need for chases or other penetrations through the CLT panels. These MEP spaces can be pre-terminated in the factory setting, allowing electricians and plumbers to work in parallel with the mass timber framers. Once the modules are installed on site, the MEP workers can continue the terminations within the module, further reducing the overall schedule. For example, the joints in the Brock Commons building use 6-inch structural screws embedded in both sides of the CLT, which provides an effective and straightforward way to connect floor joists to the CLT panels. In most cases, this is achieved by coating the panels with a fire retardant or by adding a layer of gypsum board. Acoustic insulation is another concern, especially in tall buildings where sound transmission between floors can be a problem. The inherent mass of CLT panels provides excellent sound isolation, but additional measures such as resilient channels or double ceilings may be necessary to meet code requirements. Finally, vibration control is an important consideration for high-rise buildings, since wind and human activity can cause significant vibrations. The stiffness of CLT panels helps mitigate these vibrations, but in some cases, supplemental damping systems such as viscous dampers may be necessary. Adhesives are used in glulam construction and are commonly used for gluing together the individual pieces of lumber. They can also be used in CLT construction, although they're typically used in combination with steel connectors for added reliability. The type of adhesive used needs to be compatible with the type of wood and the expected service conditions of the building. So what we really need is a robust connection system that will distribute the loads across the entire joint area. Also, be sure to check out our recent video on the exciting ways that CLT is being used in non-building applications. Now, back to the show. This works well for floor systems where point loads are transferred to the exterior walls of the building. But what about lateral loads, like wind and earthquakes? One of the easiest ways to provide this is to use cross braces between floors, which can be made out of wood or steel. These braces help stabilize the structure during earthquakes by providing a path for the energy to dissipate. But they're not the only option. Some engineers have opted for concrete cores filled with steel or reinforced concrete. These cores act as a shear wall and are heavily used in hybrid models, like the Rocket and Tigerly project in Switzerland. Tall buildings require a structural system to resist these forces, and that's where the second key aspect of CLT design comes into play, achieving lateral stability. There's also the Rocket and Tigerly project in Switzerland, which reaches 12 stories and is a hybrid model combining CLT and a concrete core. And finally, the newest, tallest mass timber building in the world is the Sumitomo W3450 in Japan, reaching 35 stories and using approximately 2,000 CLT panels. While there's still some site work and foundation preparation involved, the repetitive nature of mass timber modules allows entire floors to be completed in the factory setting simultaneously. The modules are then simply lifted into place on site, which is much quicker than the alternative. Another great advantage is that the factory setting is much quieter and cleaner than a typical construction site, which results in less disruption to the surrounding neighborhood. Some companies have even developed specialized modules that have the entire MEP system built in, reducing the need for expensive and time-consuming trades on site. In addition to those benefits, mass timber is naturally fire-resistant, provides excellent acoustic insulation, and helps control vibration, making it ideal for high-rise buildings in densely populated areas. Most commonly, modules are fabricated in widths of 8, 9, or 10 meters, and then stacked on top of each other to form the full height of the building. And just like Legos, these modules can be easily assembled and extended in any direction to create almost any building footprint. That's what we mean when we say modular. These elements are prefabricated off-site in a factory setting, which allows the rest of the building components, like the windows, exterior cladding, and MEP systems, to be installed simultaneously on-site. Then the fully assembled modules are transported to the construction site and installed by a crane. This forms an anisotropic material, which means it has different mechanical properties depending on the direction. The shear strength of CLT panels is oriented perpendicular to the layers and its primary. Strength and stiffness are in the same plane as the layers. Since all of these layers are glued together, the overall panel acts like a single solid piece of wood. And when used structurally, it can replace concrete walls, floors, and even columns. In this first of a two-part series, we are going to talk about the top reasons why this technology is exploding around the world, and in Part 2, we'll dive into the structural details of how these buildings are designed, transported, and assembled on site. So make sure to subscribe if you don't want to miss it. First things first, what is modular mass timber? Well, the term modular mass timber actually encompasses two main types of prefabricated solutions: cross-laminated timber, or CLT, and Glulam. So, how does it compare to Glulam? Glulam beams are made by gluing together individual pieces of lumber, typically edge to edge along the length of the beam. While they're also a fantastic product, their manufacturing process is quite labor-intensive, which makes them a bit more expensive than CLT, and that higher cost, coupled with the fact that they're limited to only being used horizontally, is why Glulam isn't used as widely as CLT. And let's not forget another benefit of CLT that we touched on earlier: its anisotropic properties. These distinct mechanical properties allow the material to be used more efficiently, since it can take advantage of the high compressive strength of wood to support loads. How do CLT modules fit into all of this? Well, CLT planks are usually manufactured at a width of about 3 feet or 900 millimeters. Now that we know the basics of modular mass timber, let's talk about why architects, developers, and governments all over the world are turning to this technology. Some famous examples include the Brock Commons in Vancouver, Canada, which was the world's tallest mass timber building until recently. In part 2 of this series, we'll dive into the structural details of how these buildings are designed, transported, and assembled on site. One of the biggest challenges in engineering is figuring out how to safely and efficiently transfer the load from one element to another. Since CLT is so strong and shear, the simplest way to achieve this is by using steel plates placed on either side of the joint, which spreads the load across the shear capacity of the panel. Tape panels are naturally very stable in the plane of the individual layers. But out-of-plane stability needs to be achieved through some sort of bracing or shear wall system. There are 3 main joint connection systems that are used in mass timber construction: steel plates and screws, as well as various adhesives. The third challenge involves integrating the MEP systems with the modular mass timber elements. Mass timber is naturally fire-resistant, but additional protection may be required depending on the local building codes. When assembling modular mass timber buildings on site, it's essential to have a clear understanding of the sequence of operations. With all these factors in mind, it's possible to build one floor every day. All right, thanks for watching.